This is lesson 27 of the Quantum Mechanics, a mini lecture series. So in the previous video, I talked about angular frequency. In this video, I'm going to talk about something called wave number. Now, wave number is usually given the symbol K in physics. And it's used in physics to describe how many cycles, or wavelengths, I should say, or wavelengths of a wave occur in a given distance. Okay, if you recall, lambda, Greek symbol lambda, is the distance between two consecutive peaks, okay? In other words, crests or troughs, dips. That's the wavelength. Let's derive the wave number. It's a mathematical expression. So we've got to start with the wave speed formula, v equals f lambda. If you recall, v was the speed of the wave, f is the frequency, lambda is the wavelength. I'm now going to introduce something called the period t, okay, which is the time it takes for one complete cycle of a wave to occur. It's basically the reciprocal of frequency, okay, 1 divided by frequency. In other words, if you increase the frequency of a wave, in other words, if you make more peaks compressed, you will notice less period, okay, less time for one cycle to happen, okay, because there's a lot of peaks, and vice versa. Right, if you decrease the frequency, if you make the wave longer, for one cycle to occur, it'll actually take longer. So t has to go up. We also know that v is equal to omega times k. Okay, omega is the angular frequency, it's a measure of time. K is a measure of distance, d. Angular frequency from the previous videos is 2 pi f, right, times k. Okay, in other words, the velocity of a wave involves the frequency, how many times, I should say, how many peaks pass through a given point per second at some distance, right, covering some distance, k. Now we know that t equals 1 over f. That's equal to lambda over v, because we know that f is just v over lambda, right? If you put v over lambda into here, you'll arrive at that. So here, if we rearrange this, we find that v is just lambda over t. So we can plug this into this expression here for v. So lambda over t is just 2 pi fk. Let's rearrange this. Let's get lambda by itself, so we'll multiply everything by t. So 2 pi fkt. Now we know that, I should say capital T. Yep. The period, in this case, is just the time it takes for a wave to travel a distance lambda. Okay, some distance lambda. So lambda is just 2 pi fk lambda. So the lambdas cancel out. So we get 1 is just 2 pi fk. So therefore, k is just 1 over 2 pi f. If we rearrange this up here for k. And so k, since 1 on f is equal to t, we can plug in t for f, we get 2 pi over t. So therefore, k is just 2 pi over lambda, because we've set the period as lambda, right? The time it takes for a wave to travel a distance lambda. Okay, and the wave number basically tells us here how many cycles or wavelengths occur per unit distance. That's the wave number.